Hello students, this is Professor Deepak Bora and we will be going on a journey of the chapter Indefinite Integration. One of the very important chapters in your 12th standard mathematics and also for your engineering. In this module, we are going to discuss only the definition of indefinite integration, understanding every term associated with it in detail. Let us see. Now you may have already seen the definition in 11th standard. Let us revisit the definition. So what we have here is, I have two functions f of x and g of x. If I have two functions f of x and g of x such that now they are satisfying a relation. What is that relation? It says that d by dx of g of x is equal to f of x. So two functions f of x and g of x such that first condition is d by dx of g of x is equal to f of x. Then what can we say? Then we say that integral f of x dx is equal to g of x. Integral f of x dx is equal to g of x. In general, we write it as integral f of x dx is equal to g of x plus c. That c there, that c is called as constant of integration. That c is called as constant of integration. And this above statement is read as, it can be read as integral of f of x with respect to x is g of x. Integral of f of x with respect to x is g of x. Now students, let us understand one more part of this definition which we will require in some solvings. Okay, now let us see this. I'll take this first line of the definition. D by dx of g of x is equal to f of x. D by dx of g of x is equal to f of x. Now students, if I ask you a very simple question, how else can we represent d by dx of g of x? You have studied that in derivatives. D by dx of g of x can also be represented as g dash of x. So can I write g dash of x? Right hand side, that is equal to f of x, remains as it is. So can we say what is written above is as good as g dash of x is equal to f of x? Perfect. Now let us take the second line of the definition. So it says integral f of x dx is equal to g of x. It says integral f of x dx is equal to g of x. Now some seconds back we have written that g dash of x is equal to f of x. So can I write in place of this f of x g dash of x? Perfect. So what we have is integral of g dash of x will give me g of x. Integral of g dash of x will give me g of x. Very important result which we will require for solving sums and also for entrance. Is that okay? Now let us see the terms, the terminology associated with the definition. So this is what we wrote some time back. This is what we understood some time back. What do I need to understand? What are the terms involved? F of x here. F of x is the function which we are integrating with respect to x and hence it is called as integrand. Only one name, integrand. G of x is also one of the terms involved. It is called as integral or primitive. It is obtained on integration, hence the name integral. Primitive, because integration is a very old method. It's very old in mathematics. It also has one more name. We call g of x as the antiderivative. Now we know anti means opposite. So does that mean integration is opposite of derivative? Not in the literal sense. Let us understand why it is called as antiderivative. Now, some time back we had a discussion about all these terms involved here. My concentration is on the last line there. We have understood that g dash of x means derivative. Now I am integrating the derivative. You see, we get back the function. That is, integral of derivative is giving me the function. That's what I told some minutes back. Integral of derivative is giving me the function. That is, can we say that action of derivative is nullified by integration? That means it is antiderivative. Therefore, we say integration is antiderivative. So this is all we need to know in this particular module. Thank you very much.